violent. Headless is an interesting term in software development. Like, you can say, can we run that headless? Or does this have a headless configuration? I'll be honest, when I first heard that term, I had no idea what it meant. Basically, let me paint you a picture. In this wonderful piece of terminology, a computer, like one of these things, is considered to be a human body. Yeah, this is already weird. The main part of the computer is like the actual body. And I suppose like the limbs might be input devices, like a keyboard or a mouse. I don't know. But we're coming to the important part. The head. The head is like the monitor, the screen. I guess that makes sense because it's on top. Either on a desktop, especially like the old ones where you had the main computer down the bottom and the big CRT monitor on top, or a laptop, it's like kind of on top usually. Now, if we were to take off, my head, I would be headless. And if we draw this back to computers, then we would have a computer without a monitor. So how do we use computers without monitors? Well, usually we would like remotely connect to it from another computer, like via SSH or something. And then we would have a terminal command line where we could type our commands, much like SSHing into a web server. You can of course use a GUI remotely, but for the sake of this, we're gonna stick with the command line. And that's what headless means. It's just a console application, an application without a graphical user interface. No window, no graphics, no rendering, just a command line application. Generally though, this terminology applies specifically when we have a version of that program with a GUI. Like for example, a game engine. We might want to run like all of the systems of that game engine, but just not output a video signal. This has lots and lots of different uses, from testing to running a server. Recently I made a little app called Walnut Chat, an instant messaging app that I wrote in C++ using my Walnut application framework to demonstrate networking in C++. Video will be linked above. That app has both a client and a server application, the latter of which can run either in a GUI mode or as a console app. So in other words, headless. This was important because I knew that I wanted to deploy this server onto a VPN. I needed it to run on a Linux web server that I could then SSH into and use without a graphical user interface. So I added a headless configuration to Walnut, which means that we can keep the exact same app functionality, but just either compile the program with a GUI or not. This enabled me to write the code for the Walnut Chat server just once, and then just build it in either of those two configurations. This enabled me to write the code for the Walnut Chat server just once, and then build that into two fully functioning applications, one GUI and one console. This headless app was then built on Linux and deployed onto our web server. In this video, I'm going to cover how I set up that headless configuration in Walnut and how it works. All of this code is completely open source. You can find it on GitHub. Links will be in the description below. Now, if you're new to programming and computer science and you want to learn more, then there's an excellent free way that you can do that with the sponsor of today's video, Brilliant.org. For those of you who don't know, Brilliant.org is an amazing website filled with lots and lots of brilliant courses on various STEM topics. As I mentioned, programming and computer science, they've got some excellent entry-level courses on that kind of stuff. They'll really kind of be gentle and hold your hand and take you through like thinking like a programmer, which is obviously very important. And the thing is, because this is brilliant we're talking about, they'll do that in a very visual, engaging, interactive way. It's not just gonna be, here, read this, or watch this video. It's actually going to get you to do things, to play with like all of these different widgets, and to answer questions. They'll quiz you to make sure that you're paying attention and actually learning, and that massively helps you remember things. Now, you've probably noticed from the visuals here that it's not just computer science and programming. Their math courses are honestly my favorite across the entire internet, and it's because they have this visual approach to learning. They have this engaging kind of interactive approach. Like, trust me, I do a lot of math, I do a lot of teaching, and I love this stuff. I think it's the most effective way to learn. Now, the best thing about Brilliant is that they have a 30-day free trial. So you don't have to take my word for it. You can just go to brilliant.org/thecherno and check out everything they have to offer for free for 30 days. So just give it a go, it's free. There's like no reason not to at least try it out. And if you do go on to like it, then Brilliant have been nice enough to offer the first 200 people 20% off an annual membership. Huge thank you to Brilliant.org, as always, for sponsoring this video. Right, so now I'm gonna show you how like all of this comes together and actually works. First and foremost, at its core, this is really simple. We just want to compile our code one of two ways, either with all of the stuff that's necessary to actually make the GUI work, and one without. I would definitely say that that is step one, because once you get that working, you can build what you actually need on top of that. And by building what you need on top of that, I mean alternative functionality to interface with the application. So as an example, in a GUI, you would obviously have like buttons, maybe like in the case of Walnut Chat, an actual UI control to enter your text message. If you have a console app instead, then I mean, you obviously need some kind of other interface for that, which is usually going to be the command line. You can both output to the command line, and then you can also, take in input from the command line and use that to send your messages, execute server commands, that kind of thing. So to kind of summarize, step one, just be able to compile the code with no GUI stuff in it. And then step two, build extra functionality on top of that so that you can interface where required. So of course I'm going to start with like the whole build process. I'm going to use Walnut Chat as the example here, but the fundamental library that kind of supports this is my Walnut application framework. Links of course will be in the description below. If we take a look at the root directory here of just Walnut Chat, there are two scripts. There's build and build headless. Now if we go into the actual Walnut module, you can see that there's also build Walnut external and build Walnut headless external. Now Walnut uses premake to actually generate project files. So that's why these are all kind of Lua files, and we'll run them by executing these scripts, either for Linux or for Windows, that will run the premake binary, which will be over here for Linux or for Windows, premake 5.exe, and we'll get our kind of Walnut Chat solution and Walnut Chat headless solution. Now, I probably don't need to go through these build scripts like very, very fine-grained. This code is on GitHub. You can just read through it yourselves. But I will quickly just say that this headless kind of configuration, first of all, it has this kind of workspace-wide define, and that's so that if we do run into an area of the code that is clearly GUI only, then we can just selectively compile that only if Walnut headless, isn't defined. And obviously vice versa. If we have something that is command line only, then we can also just use that define to kind of pick and choose bits of our code. Now that's not a great strategy for like the main kind of meat of things, which is why we don't use this as much as you might think. And I'll explain the alternative in a minute. Other than that, you can see the most kind of important thing here is we are including the headless external version of Walnut. So instead of build Walnut external, which is just, that's the normal one, we have build Walnut headless external. And if we quickly just take a look at the differences between these two, you can hopefully see that the Walnut external version has a lot more stuff, and namely what it has is stuff like Vulkan and like GLFW and IMGUI, none of which are present inside this Walnut external headless variant, because of course we don't have IMGUI, we don't have GLFW, and we don't have Vulkan. We don't have any graphics that need rendering. So it's kind of like a boiled down, more simple version, and of course we don't need to include these projects or link any of these binaries because they simply don't exist. This is also really useful if you're specifically compiling on a platform which might not have a GUI, or you don't support the GUI on that platform. So as an example, for Walnut Chat at the moment on Linux, it's headless only. Like we don't have GLFW and IMGUI and Vulkan and all that kind of support on Linux. I just haven't added that yet, and I didn't really need to. All I wanted to do was just run the server on Linux. That didn't require any of this stuff. So instead of kind of wasting time getting all of these dependencies like IMGUI, GLFW, and Vulkan's not really a dependency, but getting all of that stuff kind of built for Linux specifically, I just haven't had to do that because I didn't require that functionality. Now that's probably not a great example because long term I do actually want to add Linux support properly, like to Walnut. But my point is maybe sometimes you have an application that really you have no interest in kind of adding full Linux support to, but you still need it to run as a server on Linux. So therefore you don't have to kind of put as much work into that because you don't need to worry about all of these dependencies working with Linux. So that's kind of just the binaries. We're selectively including certain binaries and also certain projects, because you can see with this kind of include stuff, if we go to this kind of vendor, GLFW folder, that should definitely be uppercase. But you can see we have this premake 5 script, which obviously, compiles GLFW. So this is like an actual real project that gets included. We just simply don't need it here. And so now, since we don't have like GLFW or IMGUI or anything like that, how does our app still work? Because we've just cut out like the main core of it. Like if you have an application that has a window, that is obviously kind of core to the main application loop. Like, we use GLFW to poll all of the events so that we can see, like, is the window still open? Have we closed the window? What about like key events and mouse events? We use GLFW for that. So if you cut that out, then what does your application loop even look like? And that's a great question. And that's also why we basically need two different core application loops. We need a GUI version, which includes GLFW. It will render all of the IMGUI stuff using Vulkan, like all of that kind of infrastructure that needs to exist for the GUI version. But then for the headless version, we need a completely different application loop that basically excludes all of that, but it still runs our kind of core user code, which is written in Walnut using layers. So that itself is kind of easy to set up as well. All we have in Walnut is inside the actual Walnut directory, we have two kind of folders here. We have platform and then we have source. Source is the source code that is common to basically all the platforms. So this is like all of the core source code. Whereas the stuff under platform is stuff that is specific to certain platforms or configurations. So that might be actual operating systems like Windows, Mac, and Linux. It could be rendering APIs like Vulkan or DirectX, or it kind of could be configurations like GUI or headless. And of course, for this example, it's the latter. So if we go into platform, you can see that we have GUI and headless. And then under GUI, we have Walnut, and we have all of this code that is specific to the GUI kind of configuration. So all of the kind of IMGUI stuff, input event kind of handling, UI stuff, as well as this main application file, which we'll get back to in a minute. Image is also something that is GUI only, of course. And then if we go back a little bit to headless, you can see we also have this kind of same folder structure. And then in Walnut, we have application headless. So you can see that we have kind of two different application files, application headless and application Walnut. And what I should have also mentioned here is that the whole point of kind of separating these out inside this platform directory is so that we can only compile this GUI folder code in GUI configurations and only compile headless code under headless configurations. And it's not even just compile, it's also include. So the cool thing here that I'll just try and show quickly is that under Walnut's source directory, we have this kind of Walnut folder, right? And then under one of the platforms, we also have Walnut. So the whole point here is that when you include these files in your C++ code, you actually don't know what is coming from platform and what is coming from Walnut. Because if I add this directory as an include directory, and I also add this directory as an include directory, then the files from both of those directories are able to be included if you do like #include walnut / whatever. And that's really important because it makes stuff a lot more seamless. So the selective compilation happens inside the actual Walnut pre-make files. So if we look at the GUI build script and also the headless build script, you can see over here that under files, which are the files included for compilation, we have either platform headless for the headless variant or platform GUI. Now, these are not just files for actual compilation, they're also just files that are included in the project, which is why you're seeing header files here as well. And then under the include directories, similar thing. We have source, of course, for both of them, but then we also have platform GUI or platform headless so that we can include files in those directories by just going like #include walnut / whatever. So now hopefully this is starting to make sense. We have a GUI folder that has application GUI, and then we have a headless folder which has application headless. But that's still a little bit annoying because it means that since these files are named different things, I have to, in my application, manually type out either include application headless or include application GUI. But wait, there's a better way. Since they are actually named application headless and application GUI, that leaves room for a third option, and that is just inside the source directory called application.h. There's no CPP file for that, and what is that, you may ask? Well, this is the code for that. It just has that if def headless include this guy, otherwise include this guy. And so we're able to selectively choose which one to include, but from the client side, and in fact, even from Walnut's own internal code, all we have to include is application.h. And it will include kind of, abstracted away behind the scenes, the right kind of variant. Okay, so that is basically all of the kind of build configuration stuff that I want to cover. If we now go and open up like Walnut Chat headless, and I'll also open up Walnut Chat, which is the GUI version, I'll show you the differences in code. So one of the important things I want to touch on here is that like, if you look at these applications. So we'll look at the server because really the server is the thing that has that headless and not headless configuration. I didn't bother making a headless version of the client because I knew that would always be GUI. So under app server, we have server app. This is just a standard kind of entry point in a way for Walnut applications. And there is this little if and def Walnut headless just because we have a menu bar that obviously uses IMGUI and isn't available if the app is headless. So you can kind of just ignore that. But aside from that, you can see the code is identical. Like this project, I guess I should point this out. This project here, these actual kind of bits of code here, they're for both versions. So we didn't create two different applications that would defeat the whole purpose. We still want to retain as much original kind of, I guess, GUI code as possible when we make that headless variant. And not specifically GUI code, if I'm being pedantic, but just kind of general application code. So this will push the server layer on, and you can see the server layer has all of these functions that are overridden that we can use to, you know, actually like start the server when the layer is attached to the application, as well as, you know, on update, do things like ping the client list to everyone, save the message history. So all of this stuff is actually common to both the headless and GUI versions because, you know, we still need to do these things. Now, on UI render clearly is specific to GUI, so that's again behind this little Walnut headless thing. Now, there are more clever ways technically to set this up. If you really don't like these if and defs, you could make another CPP file that is selectively compiled only in the kind of GUI configuration that contains all of this, because it's not like you have to implement this function in this specific CPP file. But for this kind of Walnut chat thing, like I really didn't want to overcomplicate things. I just thought this actually ended up being cleaner. So this basically we don't do, but everything else here, like if I just look at this Walnut headless and just like search for it, so this we don't do, and yeah, that's it. So everything else here is common to both the headless version and the GUI version, which is great. Now, if we go back a little bit just so that we can see the actual kind of way that this application works. So again, we have application, and then inside here, we have either headless or GUI, as I mentioned. If it's application GUI, then, well, this has a lot of stuff. And I've talked about this many times. This is definitely not the cleanest file I've ever written. And it's like 1,000 lines of code that just does kind of application stuff and IMGUI stuff and Vulkan stuff. So this is kind of the meat of it. But meanwhile, we have this application headless version. If I switch to the headless solution, so this is now the headless solution, you can see it's including this one instead. And if I go to that code, you can see we have kind of the same rough stuff here that's required. We still have like a name, a width and height, which is a little bit redundant, but the reason why that's there is because if we wanted to, we could still kind of, you know, specify a width and height for the window that could just simply be ignored. Otherwise, we would need to have two different specifications or selectively compile. It just gets a bit annoying. And then if we look at the implementation file, it's not 1,000 lines of code, it's 84. It's much less, but it still follows like the same principle where we have obviously, you know, layers that are being attached, and then we have a run loop, which is while running, we go through and we update every layer as you would expect. We still actually have the frame time and the time step being reported as you would expect. But then we have this like sleep duration so that we can just kind of release that thread and let it sleep for a bit. And that is specified by the actual application specification, because you might want your server to kind of be a bit more responsive, update a little bit more, or you might really just want to run it, I don't know, once per second, which is also fine. Now, it is worth noting that like, you know, when we have applications that have UIs, we usually limit this kind of application loop to be no more than the monitor's refresh rate. So if we have a 60 hertz monitor, we run the loop 60 times per second. If we have 144 hertz, 144 times per second. That's really easy to do because as long as we have an app that actually renders stuff, especially using like a graphics API like Vulkan or OpenGL, we can just wait for VSync. And what happens there is we'll still kind of effectively do the same thing as sleeping, but it's handled by the graphics driver for us. This is very simplified. Obviously, in like a game engine, you would have different loops running at different frequencies for different things. Not everything is necessarily about rendering and thus tied to VSync, but that is still nevertheless a common thing to do. Here, we don't have any graphics API. We don't have the concept of VSync. We can run this loop as fast as the processor will run it, but we don't want to do that because that will fully saturate a core. And if we really only have a little bit of work to do at regular intervals, we can just set an arbitrary sleep value and that should be fine. So that is what that is for. That honestly, I think covers like the main bulk of it, and certainly covers step one, which is just getting those kind of two configurations running. But then we come to step two, which is the interfacing system. How do we interface with with this. If we take a look at the GUI version of the server, we have down here this message box, we have this send button, we have like all of this kind of message history. If I write something, you know, I can type it in, I can send it by just hitting enter or pressing send. Like we have obviously this UI, this user interface that we use to kind of communicate to and from this computer application. So the headless version obviously also needs that. And if I run the headless version, you can see that we still get our message history, we're still listening, and I can still write, you know, hello from headless. I can still write, you know, chat messages, and I'll get them here. And of course, if I had clients connected, it would send that message to clients. And if clients were writing stuff, I would see it here. I can also run certain commands like kicking, you know, a client, which obviously there's no one connected here. So in this scenario, it's kind of easy to create that interface because what we have in the GUI version is almost like just a GUI version of this, of a normal kind of command line. It's like literally just a console. So to make that happen in server layer, I just have two versions of this kind of console. We have a Walnut UI console, which is just the kind of IMGUI version of the console. You can see down here that it uses IMGUI to actually render like that big kind of message box, I guess, that big text box with the history, as well as like, you know, this input text that we can use to write the actual message, you know, the send button, all of that stuff. And then we also have a headless console, which, you know, is similar to UI console, but for non-GUI builds. And the way that that works is because, you know, obviously just rendering the messages and being able to send messages, that's just one function of this API, of this class that can be abstracted away. Really what's important is being able to know whether or not we've actually written something and sent it so that we can then send it to all the other clients and echo it back into the actual message history, as well as displaying messages that we've received. And so that's why the Walnut UI console has an API for adding messages. So we have quite a few options here because we can display it with an italic font, we can display it with a color, we can display it like bits of it in bold, all of that kind of stuff. And so if we simply want to display a message in that console, we just call one of these functions. And then we also have this set message send callback function, which that will just set this kind of message callback. And then if we hit that send button or we hit enter, it will just call that callback with our message buffer. And then back in the server layer, you know, here it is, set message send callback to this send chat message function. We can go back and either run the command if it exists, or actually send that chat message to all the clients. So you can probably tell here that there's no reason why that same API of just adding messages and also setting a message send callback, why that same API can't just apply to a regular terminal kind of console. And of course it can. Now, a lot of these guys won't work, meaning like, you know, this italic font or like add message with color. Color, of course, we could do, but I didn't bother doing that. That doesn't really have to be implemented. It can just print the message as normal. But the point is, in the UI version, it added it to the message history, whereas in the headless version, it just uses cout to print it. And then with the set message send callback, well, what we have is we have an input thread. So a special thread that we create that literally just sits there trying to read like the line that we type out and hit enter to. And then if that happens, we call the message send callback so that we can then again send that message. So we do fundamentally have two different implementations, but with identical API, meaning of course we can call them interchangeably. And the way that that's done is inside server layer, we just have, if it's headless, then, you know, use the headless console. Otherwise, use this Walnut UI console. And if we go down here, again, the API is identical. Over here, we can just call add tagged message, which will either add it to the message history and then use IMGUI to render it, or just cout it. The message send callback, of course, is the same. On UI render is only called if we're not headless. So that's how the IMGUI stuff gets rendered. But otherwise, you know, if client disconnects, we just call this. The message send callback, we'll just call send chat message. It doesn't know if it's come from a headless console or not. The point is that this API is identical. Therefore, it really doesn't matter if it's this or if it's this class. They're the same. Now, you could have set this up using just like an interface of just pure virtual functions and then two different classes which implement those functions. That would probably be like the traditional kind of object-oriented way to do this. I honestly saw no need to do this, especially for this example. This was just a little bit more straightforward, although I could see a version where the actual ending kind of resulting code within this layer would have been cleaner if the interface abstracted the implementation away, and then you could like selectively compile, you know, the GUI version for GUI builds, headless version for headless builds, and then have like either a compile time or a runtime branch that just picked one of the two implementations, and that would be fine. That's how we actually handle multiple kind of different rendering APIs like Vulkan or OpenGL in Hazel. But again, you have to draw the line somewhere, and for this example, I thought this was fine. And that's really all there is to it. It's not that difficult. Remember, if this stuff is kind of confusing you, just remember, I need GUI stuff for the GUI version, and I need non-GUI stuff, command line kind of only stuff for the headless version. How am I going to problem solve that? How am I going to set up those kind of two different ways of writing this application whilst keeping as much common functionality as possible? Meaning I'm not going to write two versions of the app. I'm just going to write one core version, and then just the interface and the graphical stuff, that stuff is going to be selectively picked. Just keep that in mind, and feel free to obviously read the source code, links in the description below. Now, headless configurations are not something we currently have in Hazel, but that definitely is going to be coming because we want to be able to do more networked stuff and potentially better testing as well. So it is really, really useful to be able to build your engine or your application framework or whatever in a headless configuration. Hope you guys enjoyed this video. If you did, please don't forget to hit the like button. As I mentioned, all of the source code will be on GitHub for free. Links will be in the description below. If anything in this video is confusing to you, the code might help clear that up, so definitely check it out. And also don't forget to check out brilliant.org/the Cherno. I will see you guys next time. Goodbye.